In FEC subject Unit 1, Electrical Circuits and Magnetic Circuits. In magnetic circuits, we have the syllabus Faraday's laws of electromagnetic induction and mutual induction, and circuit analysis, series and parallel magnetic circuits. This is the syllabus regarding Unit 1. Another part is magnetic circuits. The first part is electric circuits and second part is magnetic circuits. Coming to Faraday's laws of electromagnetic induction. What is Faraday's law? Faraday's law is the basic law for electromagnetic induction. How an EMF is generated in any conductor. That is Faraday's laws of electromagnetic induction describes. Faraday's laws of electromagnetic induction, also known as Faraday's law, is the basic law of electromagnetism. Find how the magnetic field interact with any conductor. Faraday's laws of electromagnetic induction basically use it to produce how the EMF will be produced. Faraday's law, that is. The phenomena of producing an EMF when magnetic flux links with the conductor, an EMF will be generated in the that is known as electromagnetic induction. This law proposed by Michael Faraday in the year 1831. In the year 1831, Michael Faraday proposed a law, electromagnetic induction, 1831, Faraday's law. Basically, Faraday's laws are two types. One is how an EMF is generated, and another one is what is the magnitude of EMF generated. First law explains how the magnitude EMF generated, and second law explains what is the magnitude. Faraday's laws of electromagnetic induction consist of two laws. One is describes how an EMF generated, and what is the magnitude is second law. The first law, Faraday's first law, let us go for that. Faraday's first law of electromagnetic induction. The discovery of first law electromagnetic induction based on long series of experiments carried by Michael Faraday. Basically, to find anything, a series of experiments will be carried out. From the experimental observation, the Faraday, whenever magnetic flux links with the coil, magnetic flux across the coil changes in time. That means whenever magnetic flux changes with respect to time, an EMF will be generated. Therefore, Faraday's first law of electromagnetic induction states that whenever conductor placed in a magnetic field, an electromotive force EMF will be generated, induced. That's why it is called Faraday's laws of electromagnetic induction. If the conductor is closed, an EMF will be generated already. If the conductor is closed loop, a current will flow. That is called induced current. Similar way, transformers also works on this principle, Faraday's laws of electromagnetic induction. Whenever conductor is placed in a time varying field or varying magnetic field, an electromotive force is induced. The conductor circuit is closed, then current will flow, induced current it is. Induced EMF will be there in transformers and generators. But static EMF is there in transformer. Okay, first law of electromagnetic induction is whenever conductor is placed in a time varying field or varying magnetic field, an electromotive force is generated. That means whenever conductor is placed in a magnetic field, direction is north to south, then an EMF will be generated. When it will be, if the field maybe varies or conductor maybe moves. Suppose a magnetic field is moving, the conductor stationary, that is statically induced EMF in case of transformer. But in case of generator, the magnetic flux is constant or stationary, but conductor is rotating. In case of generator, you can see rotor rotates. That EMF will be generated. Dynamically induced EMF will be there in generator. The first law says that whenever conductor placed in time varying magnetic field, an electromotive force is induced. If the conductor circuit is closed, current is induced, which is called induced current. It is. Magnetic flux links with the coil, an EMF will be generated. Faraday's second law states that the Faraday's second law is magnitude of induced EMF, how much induced EMF will be generated. The Faraday's second law states that EMF induced in a coil. Already first law states that whenever magnetic flux links with the coil and time varying field produces EMF. Now the magnitude of induced EMF is equal to rate of change of flux linkages. The magnitude of EMF in a coil is equal to rate of change of flux linkages. that is E equal to minus n d phi by dt. d phi by dt is the rate of change of flux linkages, n into d phi by dt, but direction indicates it is opposing the nature, minus n d phi by dt. That means the flux is the product of number of turns in the coil, and the flux associated with the coil is formula by E equal to minus n d phi by dt. Simply E equal to minus n d phi by dt is the formula for second law, minus n d phi by dt. That is, this is the second law. Now simple question, what does Faraday's first law electromagnetic induction states? Faraday's first law is, whenever conductor placed in a magnetic field, an electromotive force is induced when there is a flux linkages, rate of change of flux linkages, then an EMF will be generated. That is second law. What does Faraday's second law electromagnetic induction states? How it will be? The Faraday's second law states electromagnetic induction, EMF induced in a coil is equal to rate of change of flux linkages, E equal to n d phi by dt. Why are Faraday's laws are important? Another question. Faraday describes how changing magnetic field can use to current flow in wires. That's why it is very important. Changing magnetic field produces a current. What does negative sign indicates in Faraday's law? Because the negative sign indicates the direction of induced EMF always opposes the magnetic field. What is meant by EMF? Electromotive force. It is the energy. Electromotive force is the measurement of energy that causes current flow through a circuit. These are the Faraday's law. Next we go for self and mutual inductance.